Hello everyone and welcome to the session about the next frontier, microfrontends. My name is Florian Rappl. I'm a solution architect at a small Munich-based company called Smapiot. We are mainly concerned about IoT and embedded computing. We have a lot of projects in the digital transformation space. And to combine all these areas, we are doing a lot of distributed web applications. And that's also, of course, the touch point to this talk about microfrontends. Besides my professional work, I'm also an open source enthusiast. I'm a Microsoft MVP in the sector of development tools now for 10 years. I'm doing mostly projects in the .NET and web space, JavaScript, TypeScript these days, and I'm writing a lot of articles for various blogs, magazines, and sometimes even a book. And my most recent one is called The Art of Microfrontends. You can get it on Amazon, and it will go from, let's say, the basics up to all the patterns, implementations, organizational aspects, and so on. So much more, of course, than we can cover in one talk, but be assured we will touch the most important points in this talk. That being said, let's start with a motivating example, shall we? Let's say we are looking at a system architecture as it is done quite often these days, which is, of course, you know it, microservice based. So let's say we have services A, B, and C, which are user-facing. And then we have maybe some auxiliary services, in this case, X and Y. Now, why are we choosing this kind of architecture for backend? Sure, quite often it's chosen for the wrong reasons, but some good reasons maybe that, yes, what we want is to scope these services around business capabilities so that we can say, oh, this service A, it's maybe the invoice service, it only deals with the invoices of whatever kind of business domain we want to cover. And the service B may relate to products. It's our product service, product info service, whatever you want to call it. It only deals with that, right? And so we get really autonomous teams assigned to these services, and they really are then domain specialists as well. So the caretakers of service A, which is the invoice service in this example, they really know everything, the ins and outs of invoice, know all the taxes, what that means, maybe for different countries, etc., etc. So that's really a specialist team then. But as you can see already by this example, there's a lot more knowledge required in other domains, like for instance, tax systems of the various countries, to actually have service A implemented correctly than, for instance, service B, which only deals with product information. And therefore, of course, it makes sense that a service like the invoice service will have a lot more deployments, things that break, things that need to be updated, etc. And therefore, assigning these services their own development and deployment life cycles is really crucial. Now, you can only achieve this goal of having, let's say, autonomous teams and independent deployment life cycles if you loosely couple your services. But you gain also something else if you just have various services for the various domains. You can now write these services in a technology independent way. Meaning that if there is, for instance, already, a library in a certain language, let's say Go, that makes your solution, for instance, for the invoice service, much simpler to implement, then you can go for that. However, of course, that always has the danger that in the end, you might end up with kind of a patchwork system, right? Where everything is, let's say, written in another language or framework. And so for one person to just do maintenance work on a service that, that person never touched beforehand is really difficult. Okay, that, let's say, left aside, let's look at the front end here. And quite often, you end up with a single front-end solution. So you have all these nice decoupling and everything on the back end, but on the front end you have a monolithic architecture. And that's, of course, developed by usually one larger, very central team that gets hammered by all, let's say, the changes of the back end. But why are you doing that? Well, you're doing that usually because it's the best thing for the user experience, right? So you get an integrated and very consistent user experience. That's almost guaranteed here. It's just one thing. If you change, I don't know, layout of a button, if you architectured it right, the button component, every part that uses it will just be impacted by that. And so it's always consistent. And if you change something, chances that you keep the consistency on the user flows intact are quite high, because you own everything. You just see everything, and there are not so many moving parts that are not in your hands here. It's all just one single solution. The downside is that deployment releases are also, of course, quite large, and that means if there's just a single hotfix to be done, it can be quite difficult. You might need to cherry pick. You might need to go to everyone and say, hey, is your feature already ready? What can we pick already from there? That can be really intimidating. Also, of course, even if the alignment is for whatever reason simple, build times, etc., might still be quite large. So if a hotfix should be deployed within minutes, it might be challenging to run at least all the tests against this huge thing, the whole build, etc. I mean, that altogether might take half an hour to an hour easily if it's a medium to larger sized application. So what is the solution to that? Yes, sure, you guessed it, right? From the title of the talk, it might be to go to microfrontends. So how does a microfrontend architecture look, let's say, if we would derive it in a vacuum? Let's say we have now our user-facing services A, B, C, and D. These are microservices. And the easiest thing we could do is we just place a front end on top of each of these microservices. So service A gets front end A, service B, front end B, etc., etc. So far so good, right? So now instead of just serving, let's say, some JSON here, we serve some HTML, and that's great, it's cool. Now the downside is, of course, how do you make that now a consistent user experience? Because they're all independent. So our service A, remember, it was, let's say, invoice service. Now gets an invoice front end on top of it. So if you would go to the URL that corresponds to this server, you would see a list of your invoices, for instance. Now you can go on invoice details, that's nice, but you will not see the product details in there, right? Because, I mean, that's coming or is rendered from a different front end. So you would just see product IDs maybe in there. That's not a good user experience, because, yeah, maybe the link is already there and then it jumps to the product details, which is hosted by this front-end B server. But yeah, that's not what you want. You want everything on one page and it should look nicely, and you may want already the preview image of this product, etc. You don't want to lose that just because now you have independence of all your different, let's say, domains also in the front-end space. And so that's the reason why the story with microfrontends is not over yet with this simple picture. That's the reason why there are now certain patterns to actually implement it, because, yeah, as mentioned, at the end of the day, it's now all about how are these independent pieces coming together to form a consistent user experience. There's a whole range of patterns. Just to mention two of the most popular ones, you could call them the ends of the spectrum, right? On the one hand, you have something like server-side composition. What happens here? The browser sends the request, okay, I want to open that website, and the request ends up at a reverse proxy. Now the reverse proxy can resolve, for instance, that page, I know that one, it's hosted on server 1. So it goes there, and that returns, of course, some HTML. Now that's not the full HTML we want to serve. That has still some holes in there, some placeholders. Now this reverse proxy does two things. On the one hand, it knows the syntax for these placeholders. That might be something like server-side includes or edge-side includes. Whatever we pick there might be your own templating language. The only constraint is the reverse proxy needs to understand it, right? And the second thing is it needs now to also change the asset URLs, etc. So if you have an image in there, I mean, server 1 is not seen from the outside. it must transform it in a way that, you know, the asset URLs are then again ending up at the reverse proxy, which then forwards them to the right server. So it still has a little bit to do. But nevertheless, so it sees now our placeholder, oh, that's on server 2, so it goes there, it grabs the resulting HTML and it places it on this position. And of course, that can be recursive. So now this, let's say, yellow box that we received from server 2, that might return another placeholder, etc., etc. And so these things can be quite, yeah, let's say, cumbersome to manage, but in the end, what we receive in the browser is the full HTML. No need to do anything more there, and you just receive a page as you would have done beforehand. And so, as let's say a browser, you don't need to do anything more than, you know, without a microfrontend architecture. All the work is done on the backend already. Great. Now the other end of that spectrum is something like a client-side composition, right? Again, request will hit the server. In this case, no reverse proxy, but directly server 1. So that's now user-facing. And it returns back some HTML, nice, and a script. And that script is a so-called orchestrator. So it knows where other scripts are located and what to do. For instance, in order to fill out the placeholder, it might need to go to server 2 and load another JavaScript, maybe with some additional data. And now this little JavaScript there, it can now render and fill out our placeholder. So things like that might be really good if you think about something like an island architecture, which is now an emerging thing or an older thing, but getting popular again. But you can really go on and think about it a little bit more and have your whole solution around just client-side rendering, where you say, okay, I know, for instance, I want already to start with a single-page application, so highly interactive web application. Why should I actually invest in all that server-side logic? If there is no real gain from it, why not make it directly combinable in the browser? It also can have several advantages because it's really easy to cache for the browser. So first time startup or might be a little bit slower, but then it can be really, really fast, and you can really have very dynamic solutions that just feel like magic from not only user perspective, but especially also developers perspective. Right. So that, let's say, is the extreme spectrum. So let's take a step back here and let's see what we actually want to have in whatever solution we want to implement. So our desired solution is a little bit the combination of the aspects that we've seen from microservices, but also preserving some of the key points from a monolith, namely the user consistency. So for an end user, it should never feel like, oh, that was composed out of different pieces. No, it should feel like this is one solution, right? So when you sit down in your car, you're also not thinking, oh yeah, the dashboard came from that manufacturer and the engine came from the other. No, you just say, oh wow, that's a nice car. It really feels like a slick experience. Even though, of course, no car vendor ever has built everything just on their own. They always have lots of vendors and they get all these parts and then just assemble it together, right? That's the same thing that you want to have here. So for the end user, it should really feel like one thing. That's what I would call, it's a best of both worlds approaches for a modular distributed web application, right? And modular is really a keyword here. Now, how are these modules actually purposed? Well, they're purposed around business capabilities. Same like what you did with microservices, right? So you put business capabilities into modules. It's great. Now, you don't want to load everything, right? It might be even too much. What user is using all aspects of whatever business you're in, right? Even the example is the invoice, right? That might be like a web shop. And just because you use that web shop doesn't mean that now you are actually required to also look at invoices. Actually, you're not. Most of the time, you will not review your invoices there. So you really want to have a loose coupling here, that you just load it when you need it. Now, there are certain aspects that you want actually to already have unified in your application, like some architecture decisions. For instance, all your backend calls, how should they be authorized, right? Are they taking, I don't know, a JWT, for instance, or is it their cookie or whatever, right? So these things you may want to decide up front. Also, what is very important, the consistent UI UX, right? It's all about consistent UI UX. So maybe you want already to share something like a pattern library where things like a button, a drop down, whatever, right? Really uniform standard UI components are already in there. Great. And with all that in mind, sure, you want to scale up, right? It's all about scalability. Therefore, development should be possible by independent teams. Now, that's the spectrum. That's what you want to have, in my opinion, in most of these micro-frontend driven solutions. Now, with that in mind, let's look at our micro-frontend architecture and let's see how it changes. You remember A, B, C, and D, the independent web servers. So there were full applications. You would need to host them somewhere, but then they would just be somewhere. And at the end of the day, the major problem you will face here is how are they, let's say, coming together? Now, what you can do is you just put them together in an application shell, a so-called app shell. In that app shell, you now have different modules, A, B, C, D, but now they're modules, right? So they're not running just somewhere, no umbrella, nothing. No, they are just running inside this application, like plugins, for instance. And that's great. You can then share certain things like some common capabilities, some libraries. A library might be, for instance, a pattern library. And that way, these modules already get some things out of the box, which is awesome because they don't need to reinvent that wheel. So they can only focus on their business domain that they want to cover, which is great because at the end of the day, that's where the money flows in. They shouldn't invent a new framework. They should just do whatever they actually want to bring to the end user. Great. What does that mean for the development approach now? How does that scale? Well, beforehand, as you know, we may have had different backend teams, but we always had this one larger frontend team. If we now go a step forward and if we now see, oh, we have now this application shell and we have these different modules, then at this point in time, you got an additional dimension to cut your teams for. So one possibility is that you give your application shell, which should be rather lightweight, doesn't contain any business capability, to a dedicated team. But then you have real full stack teams that take care of something like the modules, services, etc. And if you want to, you can even then think about it in a different way. The application shell may be some backend for frontend or some API gateway. You may give this to some kind of a technical team, and then you have your full stack business oriented teams. So that's also a way you can think about it. That's not, of course, the only way to cut it. There are infinite ways. So you could even say, oh, there is a team that focuses on module A, module B, and then there is a team that focuses on module C, but since module C touches also service A, B, and C, it might be the same team or whatever, right? So you can now cut it wherever you like. The only thing is that you can now have also these cuts in the front end, which is awesome. So you have a larger piece there, a really crucial piece, just give it to it. And you can even progressively enhance that. Let's say you have something in your application shell like, I don't know, let's say a feedback form. You said, okay, just should be part of the application shell. But then you realize at some point that, there are now more and more changes coming in for that feedback form. And it's also getting more and more important. So maybe you put it in your own module. And then, of course, you can give it to a dedicated team and can say, hey, you guys, you're now responsible for that feedback form. This is all possible with this approach. So you can also progressively identify new areas, cut them out of the application shell, give them to dedicated teams. That's a possibility. Let's have a look at the user experience. How does our user experience such a solution? Let's take a very simple example. We have here some kind of a portal application. As you can see, just loads, right? So sometimes a little bit faster, sometimes a little bit slower. Just needs to get some information there from the Microsoft Graph. Okay. Yeah, we can click somewhere, right? The calendar opens, or I don't know, some kind of a time tracker. That's all nice. But all of these things are coming, let's say, from different parts. So a different developer developed this kind of portfolio list here, right? So you got a page, this is a portfolio, and you got this tile here. And another developer developed, for instance, the vacation planner, etc., etc. So different teams were doing that. And even more, behind the vacation list here, there's even a feature flag. Because, yeah, we know that the boss never takes vacation. For the boss, that shouldn't be shown. So what you could, for instance, do in the simple example is we set in the local storage an item called user type, and we set it to boss. That is exactly what the boss would have already out of the box. So now if the boss would load this application, you see that this thing is gone. Now you can say, okay, that's an if in the code. That's not really interesting, but no, there's no if in the code. Let's load this thing again. And let's see, there is this call to something with SmartBiot, user type boss. And that something with SmartBiot is the so-called feed service. It goes to feed parallel.io, and then it calls SmartBiot here with user type boss. And what it gets back is 4 items in this list, and these are the 4 microfrontends that are now in this application. So we got the posts, team calendar, customer portfolio, timesheet. That's great. Now going back and removing that boss, right? So I just clear that. Will result in a request to this feed service with user type normal, and now we get back 5 microfrontends, and the vacation in version 1.1.1 is part of that. It wasn't part of the response beforehand. So we get all this information, right? And now we have our vacation list and everything is awesome again. Quite nice. And again, this is all coming together here in the user's browser. And the end user doesn't actually realize what's happening. So it's just tailored now to that. And by the way, we got this My Vacation link here in the footer, which wouldn't be there if you're just the boss. See that again. We reload. There's no link. So everything is consistent, always. There's no if in the code, just assembled on the fly. And yeah, if it's not there, it doesn't register something for the footer, so nothing will show up, and therefore this will stay consistent. Otherwise, if you would work with ifs, think about it. What you would all need to do, you would need in your footer, oh, if, then you would have in your tiles in the dashboard, oh, if, and then on your page, oh, if. So a lot of, let's say, conditions, and you would need to keep them always consistent. So if the condition changes for some reason, you would need to change it in all those places, or at least have a function to keep it as consistent as possible. Not very easy, but this way it is quite easy, because yeah, that's all decided by the feed service if it's delivered or not, and then it stays consistent by default. Great. So what are some principles and challenges we need to follow here? We want definitely a first-class development experience, so it should not require setting up a whole backend and all that. You should just be able to start like with any front-end project. If you just want to develop a single module, you should be able to do that in seconds to minutes. With all that, you should get something like, I don't know, some templates, etc. that you can say, oh, when someone starts a new module for my application, that should maybe already contain something like, I don't know, some boilerplate code, or where some architecture decisions are already shown. Should be possible. That should all lead, of course, to distributed development of modules. It should not be required to have a joint repository or something, but really everyone can have its own repository for its own frontend module. That should just work. If some team wants to develop in a different framework, it shouldn't be forbidden, right? It should be actually supported. It doesn't mean that it's encouraged. You'll still get the best experience by, just relying on one, or let's say the least amount of front-end frameworks. But yeah, I mean, if there is this new team and they're really crucial, they do a business critical job, and there's no one else, and they only know, I don't know, Vue, but the rest of the application is using React, and why shouldn't they be able to use Vue? They should be able to do that. And sure, we want to have, let's say, the best convenience possible. That, for instance, backend services can be just accessed very easily. From, let's say, the high-level architecture, how that can be derived is the following. So users will hit a web server or static storage that delivers the application shell, which then starts loading all these modules. Their data comes from the feed service, or it's just some JSON, but a feed service would be good for several reasons. And this just leads to some other assets which are stored on a module storage. Ideally, this is some CDN, so the application shell can now go to the CDN and with really the smallest distance from the user's browser, load these assets like, I don't know, JavaScript files, HTML, CSS, etc. Now, why does it make sense to have a feed service and not just a static JSON? Well, how do you update the static JSON, right? It is problematic. You need then to have some CI/CD magic, and how do you, let's say, guard that? It's very difficult. But if you have a feed service, you can have API keys, you can guard very easily, and you can have rollbacks and all that very nicely, very easily implemented. Additionally, you can have, of course, something like feature flags, which make your whole application, as just shown, very dynamic for the end users. But in my opinion, as mentioned, biggest advantage is that the tooling can already work against the feed service. Consequently, things like publishing a new module is very easy. Now, one of the simplest ways to actually implement that is like this. Of course, that's just the gist of it. There are more aspects for real-world application, but just let's go over this simple variation. So you go to that module service, say, hey, give me the modules. Of course, it's a JSON response, let's say, and in the simplest way, it's only a list of URLs, no metadata, no nothing. So it's just strings. Each of that string is representing a URL, and what you're doing is just creating a script, giving it the right type, and then seeing when it loads, and you do something with it. And that's it, right? So each microfrontend is a script, essentially. The rest follows from there. And that just works. If you want to go, of course, beyond that, I would always suggest to use a framework. The one I'm advocating is the one that I'm actively contributing to. It's called PaLOUsa. You can visit the site at pyral.io. Otherwise, you can start it on GitHub. It would be appreciated. github.com/smapyot/pyral, but it's also linked, of course, on pyral.io. Now, we can have a lot of slides on Pyral, etc. But I would say let's just see what that might look like if you would start with Pyral. We start in the command line, and what I can use is an npm initializer, npm init Pyral instance, and then I can choose a couple of things. If I want to have a survey, maybe let's go with the survey, then I will be presented all the options that this initializer gives me. So let's wait a second till the initializer is downloaded. So project's root directory, let's call it my app. Yes, we use PyRel as we want to install the dependencies from the standard registry. We pick the latest one, nothing should be overwritten, TypeScript is always a great choice, and we use the default boilerplate template. Now what npm client, the npm is great, and then maybe let's use esbuild as our bundler. After all these options are set, they're saying now scaffold for us this template. So let's see. When the dependencies are all installed, and if everything has worked as it should, we should now see an additional directory called my app. That looks good, and we see my app is here. Let me open this in VS Code. I will not go into all the details right now, but what you should see is that we have an index TSX, which pretty much defines how the single page application works. It will render this instance, it has some layouting elements, some error components, that's fine, and most importantly, it defines where to get the microfrontends from. The microfrontends are called pilots, so it's PyRel and pilot. And with that in mind, let's just run npm start to start the debugging process. That looks good. This is esbuild, and this is how it looks like. So that's the application. It's a little bit of a sample. And what we can do is that we can change the sample, that we can, for instance, remove the default tiles and the default menu items, because, yeah, say we don't want these to show up at this point in time. We just remove the references, save it, and that's how it now looks like, right? Great, but it's still very empty, so the reason for that is that we are at the moment using also the empty feed, so there is nothing to be loaded here. Sure, we just started our application shell, so where should we get something from? But what we can, for instance, use is the sample feed. It already contains a few pilots, and even though they were made for a different kind of application, they pretty much work in any application as long as they're not, I don't know, crazy from a requirements point of view. Great, so now we got some items in the menu, and you can actually watch me play Mario 5, which is awesome. So let me get the Gampa. Nice. Can go out there, can go back again, can jump. This is all going well. I can even select something else, like the ultimate volley, right? So playing against myself here wouldn't be so nice, so let's jump back to Mario. So that's a little bit how this works. And now, of course, that I, let's say, developed my application, I didn't do much, right? Maybe I want at least to change that there is PyRel written on the top, so let's just call it my app. To have a little bit of custom branding here. We can go on and we can actually build that. So what happens when you run build? It does two things. The first is it will build a so-called emulator, and the second is it will build also release artifacts. The emulator is just a TGZ, and it pretty much can be used to emulate your full application. That's great when you develop modules, because then you will just, reference that emulator, and with that you will just be able to, develop as if you would have the full application, which is great. So it's a little bit similar to, developing an application for the iOS or for Android. there you also use an emulator of these operating systems. Now you use an emulator of your web application because you are creating an app for that, right? And the second is the actual app. That is what you would deploy somewhere on the static storage, for instance. Now these two things you get, and that's what you get in your dist. And that's pretty much how you create an application shell in PaLOusa. Of course, there's a lot more to it, but that's how simple it is to get started. I would now have an emulator for the My App application shell. I could publish it on NPM, for instance, or on a private NPM registry. And then anyone could actually develop it for it. Not everyone could publish for it right now, because yes, that feed is still protected, right? But everyone could create a module. It's again similar to iOS or Android development. Everyone can create an app for it, but getting into this door is another story, right? So how does this high-level architecture change with PaLOusa? Pretty much the same as before, and just instead of, you know, having tooling that is called the PaLOusa CLI, and this feed service implementation that we have a Pro edition, it's commercial, but we have also a free community edition, and of course some implementation samples. So if you want to create your own one, you can just do that. They of course are a little bit more elaborate and contain a lot more functionality. Now, final thing to show is of course how easy or hard you can judge it is to now develop a module for it. For that, let's go back into the command line again, and the initializer for that is called pilot. Let's do the same thing as we did before. So let's just go over the survey. You can use command line parameters to skip that survey, but yeah. So what is the source package containing a PaLOusa instance? Well, that's already a difficult question. That would be this published emulator, right? So you should choose one that's already published. I now choose sample PaLOusa. I will show you in a second what that is like. Target directory, let's call it my pilot. The registry and all these other options we can just leave as they are. The boilerplate template to be used, well, it's the default, right? And npm, let's pick ES-build because it's so fast to install again. Now what's this sample PaLOusa? This is essentially the app shell that's behind one of our demos, and you recognize already all these tiles. Now that's the sample feed, right? So yeah, the sample feed is the feed that's used by our sample PaLOusa instance, and this sample PaLOusa instance also is an emulator out there called sample PaLOusa. So what we should see when we develop another thing for it is this thing just without all these tiles, because they're coming from the microfrontends, right? And these microfrontends are not loaded by default. Now we are done. We can just look into the directory. I also start VS Code for it, and I run it. It's running. It did just show a message down here. It shows a dialog in there, and it also registered a menu item in here, which is awesome. Why does it do that? It only has an index.tsx. So what you can think of this pilot is a little bit like a library. It exports only a setup function, and in this setup function you will actually now tell your application shell what kind of components you have. For instance, do you have a menu component? Well, then you tell it about it. Do you have a page? You tell it about it. So for instance, you could say, I got a page. That's the page foo, and it should render something like hello world. So here I'm writing a little bit of React, don't be confused by that. So now if you want to, let's say, point it to that, what you could do is you just use a link. That's a standard mechanism from React Router, so anyone who's written already a React application knows that. And let me call that foo here. So now that I did that, you see foo and you see hello world, and that's great. Of course, you should maybe lazy load your page, and your page should have been written maybe in a dedicated file. So let's have a little bit of Lauren in here, and that's about it. So what you can do is you could say your page is actually maybe just lazy loaded via an import from there, and as a result this still works. But if you would reload it, let's just do that, you would see that we load another script when we go there. It's really fast, so we didn't see a loading spinner, but yeah, a loading spinner was showing up, and that just works. And I didn't need to do a lot of things now to make that work. It's already by the system that PaL provides under the hood, that this orchestration just works, and then I got lazy loading on this one page. I can do other things. So for instance, I can use a browser extension and load additional pilots. Now, if you remember from our previous application, we had a feed in there, right, that we loaded. And this feed is the same as this one. So if I refresh, you get this sample here. I can just copy it, and I have the URL, and using this URL I can add all these things. So now my thing that I develop is shown next to these other things that are already there and existing. And you can think about that similar as, you know, you develop an app for, let's say, iOS. And you develop your app, of course, in isolation, because whatever you have on your phone you don't have on the emulator, and that emulator starts from scratch, starts without any other applications. But you're of course capable of having the store there and loading other applications. So for instance, if you have, let's say, a sharing functionality in your application, you want to see if you can share it via WhatsApp, with the WhatsApp app, then you can just load the WhatsApp app and see if it works. And that's the same here. You can just now load other things, and you can see if your microfrontend works together with these other things. And you see from the menu perspective that works, and then I can go to Mario 5, I can go to foo, and that just works here. Awesome. And that's how you would develop a module. At the end of the day, when you are finished with your module, you can just build it, and that will, of course, like with the application shell, give you all your artifacts. You're done. As you can see, they are really small. Yes, we didn't do a lot of things here, but they're just usually quite small. The individual parts, they're really micro. That's it for my talk. What did we cover? We started with a generic microfront architecture. We specialized that. We derived an architecture for modular web applications, the best of both worlds, monolith, microservice, brought together now for the front end. And in the end, I showed a little bit what PaLOUsa can do, a framework for modular microfrontends. Tomorrow in my talk about serverless for frontends, I will go into more details, and I will show an example application based on a Netflix clone, how that works together, how you compose the different domains, and I will show you also how the publishing works and how easy that is. I hope you had a good time. I hope you learned one or the other thing. Any feedback appreciated. Follow me on Twitter. Have a great day. Have a great conference. See you all around.